So then in interest of time, the idea here, right, is that we have this phosphohistidine. We know that in the intermediate, we need to have a phosphate on carbon 2 and carbon 3, right? And on your sheet there and up here, we see that the reactant only has a phosphate on carbon 3. So the first step must be activating this oxygen to be a nucleophile so they can attack this phosphorus, which is really electrophilic. So we can propose having a general base in the active site, which picks up the proton from that oxygen. The oxygen then becomes nucleophilic. It attacks the phosphorus. We break the bond between the phosphorus and our histidine side chain. This gives us our intermediate. Oops. Where'd it go? Went the wrong way. There we go. This gives us our intermediate. Once we have our intermediate, right, we now have the histidine that does not have a phosphate on it. So the idea is that we're going to rephosphorylate it, but this time the phosphate's going to come from carbon 3. So I'll draw it over here. So we have our histidine, acts as a nucleophile. It attacks the phosphorus. We break the bond between the phosphorus and that oxygen, giving us an alcohol group on carbon 3 and our phosphate group on carbon 2. So hopefully straightforward SN2 chemistry. Okay, so if we kind of zoom into the active site, we see that everything is here that we need. We see that carbon 3, right? So carbon 3 here has the phosphate on it originally. Carbon 2 is positioned here. And the idea is you can kind of imagine this being able to rotate a little bit. So this right here is the position where the phosphate would be on the histidine. So this would be phosphohistidine right here. Carbon 2 is in good proximity to react with it. This histidine is also in close proximity to carbon 3 here to be able to strip the phosphate off of there. So we would have a phosphate here. Carbon 2 reaches out, removes it. You now have a phosphate on carbon 2. This histidine no longer has a phosphate. It can reach out, remove the phosphate from carbon 3 in a very irreversible manner. The idea is just understanding that the phosphate on histidine can kind of be shuffled around. We always go through this intermediate that has a phosphate on carbon 2 and carbon 3. This sets us up for really the last big step, right? It's ultimately the dehydration step that produces phosphoenol pyruvate, our second high energy phosphate compound that we can use to make ATP. Okay? So go ahead and take a few minutes and try to think about this mechanism yourself.